In this video, we're going to look at the concept of circle geometry for this exam. After going through this video, I guarantee you guys that you'll be able to deal with problems involving circle geometry. So ensure you stay to the very end of this video because I'm going to simplify the idea behind it. Okay, so let's go into the details of the video. Let me read this diagram that shows various rules for circle geometry. Okay, so let's look at this diagram and continue from here. Okay, now when I look at this chart I have here, it says circle theorems. Alright, so these are the rules for circle geometry. Okay, now the first one we have here, let's begin with this first one here. It says alternate segment theorem. Now this theorem states that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. Okay, now the second one I have here says angle at the center theorem. It says the angle at the center is twice the angle at the circumference. All right, don't worry, we're going to practice with a question and apply these rules to them and see how this will rather apply to such questions. Okay, now the third rule I have here says angles in the same segment theorem. Okay, it says angles in the same segment are equal. Okay, the fourth one says the angle in a semicircle is 90 degrees. Okay, the fifth one says chord of a circle. It says the perpendicular from the center of a circle to a chord bisects the chord. Alright, which basically means that it splits the chord into two equal parts. Now the sixth one I have here says cyclic quadrilateral. Okay, circles that involve cyclic quadrilateral. It says the opposite angles in a cyclic quadrilateral, alright, total 180 degrees. Now the last one I have here says tangent of a circle. Okay, now we have diagram A and diagram B here. So it says the angle between a tangent and a radius is 90 degrees. Okay, the B diagram says tangents which meet at the same point are equal in length. Okay, so guys, you just have to know these basic rules. All right, you have to commit them into memory. Okay, it will help you a lot in dealing with circle geometry problems. All right, so having known this, let's get a practice math question and see how we can apply any of these rules we have on such a question to solve it. So let me get this question, let's solve it together. Okay guys, now let's start this question. This is a circle geometry question. It says A, B, C, D are points on the circumference of a circle and angle O is the center of a circle. Angle ADC equals 109 degrees. Work out the size of angles ABC and AOC. Alright, now firstly we will probably have to use more than one rule to solve this circle theorem problem. Now if you look closely, you will observe that this is a cyclic quadrilateral. Since this is a cyclic quadrilateral, we have to make use of this rule here, which says that the opposite angles in a cyclic quadrilateral total 180 degrees. Okay, now that we're going to make use of this cyclic quadrilateral rule, now when you look closely or look at this question, you also observe that angles ADC and angle ABC are opposite. Okay, so we have angle ADC and ABC, okay, are what? Opposite. Let me write it. Are opposite. Okay, now since they are opposite, angle ABC will be 180 degree minus 109 degrees. Okay, so when you punch in the calculator, you're going to have it to be 71 degrees. All right, now that we have angle ABC and angle AOC both come from a chord AC. Okay, this AC angle AOC, this middle one both come from a chord AC. So we have to make use of this rule to solve for angle AOC. That means we are going to make use of this rule number, this one involves center. Okay, this rule, we're going to make use of this rule, angle at the center theorem. Right, it says that the angle at the center is twice the angle at the circumference. Okay, now that we are going to make use of this rule, that means our angle AOC is double angle ABC. All right, so angle AOC is double angle ABC. Okay, now that we have angle ABC to be 71 degrees, therefore AOC will be 71 degrees times what? 2. Okay, so when you punch in a calculator, you're going to have it to be 142 degrees. All right, so that will be the answer to this question. It's as simple as that, guys. Okay, so let's recall what we just did. In the question, how we found 71 degree, ADC, this is a ADC, all right, and ABC are opposites. All right, since they are opposites, we made use of this cyclic quadrilateral, and we have a cyclic quadrilateral here. The opposite angle in cyclic quadrilateral theta 180 degrees. All right, so to get ABC, we need to subtract 109 degrees from 180. So when you do it, you get 71 degree. The next question says AOC. Now, since angle ABC, which we just found, and angle AOC both come from a chord AC, okay, we have to make use of this rule now, which states that the angle at the center is twice the angle at the circumference. Okay, that's angle at the center theory. So since this is what the rule is saying, our angle AOC, all right, we have to be doubled angle ABC. So angle AOC is double angle ABC. To do it, now our ABC is now what? 71 degrees. Now the double of AOC will now be 71 degrees times 2, which will give us what? 152 degrees. Okay, so it's as easy as that. Now let's wipe this and look at one more circle geometry problem to solve, and after it we can call it a class. Let me give you guys this practice question, all right, to test some knowledge on this. Let's wipe this. Okay guys, now look at this question. It says A, B, C, and D are points on the circumference of a circle with center O. The line EF is tangent to the circle and touches the circle at D. Angle ADE is 63 degrees. Find the size of angles ABD and ACD. Now feel free to pause this video and see if you can figure this out. This is very, very simple. Don't need to solve anything. Just look at these circle theory rules we have here and see the one I'm going to apply to it and get your answer. Very, very simple question. Alright, so feel free to pause this video and see if you can attempt it. Okay, let's do it together. Now, looking at this question we have here, we're going to apply this rule. Alright, angles in the same segment theory, because this is basically the rule we're going to apply. That's the kind of shape we have here. Now, the angles in the same segment theory states that angles in the same segments are what? Equal. Alright, since angles in the same segments are equal, that means we have our ADE to be 63 degrees. That means our angle ABD will also be what? 63 degrees, and our angle ACD will also be what? 63 degrees. Reason is that angles in the same segments are what? Equal. So it's as simple as that, guys. So this is basically how you can deal with problems involving circle geometry. Once you give me a question, just check the rule that I applied to it and apply it, and you'll be good to go. Hope you learned something interesting from this video. Now, if you are new to the channel, check the description of this video below. You see a link to our Telegram channel. Click on it and join the Telegram channel for instant notification. Also, ensure that you are subscribed to this channel by hitting the subscribe button now for more videos like this. Like, share, and comment on this video. Tell me how you feel from what I've learned from this class. If you seem to have any specific questions to ask regarding circle geometry, feel free to leave a question in the comment section below, and I'm sure to give you guys a response. That's it for this slide, guys. Thanks for watching. See you in the next video. Now click on the end screen above and I'll see you in the next video.